You've been spending quite a bit of time with quantum computing lately, right? Specifically, this Microsoft Majorana 1 chip.
Yeah. Yeah, it's definitely caught my attention.
From what I can tell, you're really trying to figure out if this thing can really live up to all the hype.
Exactly.
And well, you gave me this report on the Majorana 1 chip, and let me tell you, it's a fascinating read.
It really digs deep, huh?
It does. It really gets into the nitty-gritty of how this chip could be like the missing piece of the puzzle for quantum computing.
I mean, there's a reason everyone's talking about it.
For sure. But before we get too deep into the weeds with this Majorana 1 chip, I think it might be helpful to take a step back.
Okay, sure.
You've been looking into quantum computing for a while, but for those who are just tuning in, can you give us a quick rundown of why this whole field is such a game changer?
Absolutely. So, at its core, quantum computing is all about harnessing the weirdness of quantum mechanics.
It's like a whole different set of
Yeah.
rules, right?
Exactly. And it lets us perform calculations in ways that classical computers just can't even fathom.
Okay, so we're talking about that whole a bit can be 0 and 1 at the same time thing?
That's superposition, yeah. And it's one of the superpowers that give quantum computers their edge.
Edge.
Well,
Yeah.
think about it. Classical computers use bits, which are basically like tiny switches, either on or off. But quantum computers use qubits.
Okay.
And these qubits can be in multiple states at the same time. It's like they're juggling possibilities.
That's wild. But there's more to it than just superposition, right? Didn't you mention something about entanglement?
Right. Entanglement is where things get really spooky. It's like this invisible link between two qubits, no matter how far apart they are.
Okay, hold on. So if one qubit changes, the other one instantly changes too, even if they're miles apart.
You got it. It's almost like they're communicating faster than the speed of light.
That's mind-blowing. Okay, so we've got these quantum properties, superposition and entanglement, and they give quantum computers this crazy advantage over classical computers.
Exactly. We're talking about solving problems that would take classical computers millions of years, maybe even longer.
So we're talking about problems that are basically impossible for us to solve right now, even with our best supercomputers.
Precisely. Think about it, simulating complex molecules to design new drugs or optimizing global logistics networks. These are problems that could be tackled by quantum computers.
And what about cryptography? I keep hearing about how quantum computers could break all our encryption.
That's a real concern, and we'll definitely dive into that later. But it just goes to show how powerful this technology really is.
It's exciting, but also a bit scary, huh?
Yeah, there's definitely a sense of awe and maybe a little bit of trepidation.
So all this potential is incredible, but there's got to be a catch, right? Building a quantum computer can't be easy.
You're absolutely right. There are major hurdles. One of the biggest is that qubits are extremely fragile. They're like divas demanding absolute zero temperatures and constant pampering.
What do you mean by fragile?
They're incredibly sensitive to any kind of disturbance. Even the slightest change in temperature or a stray magnetic field can cause them to lose their quantum state.
And that leads to errors, right?
Exactly. It's called decoherence, and it's one of the biggest headaches in quantum computing.
So it's like trying to build a sandcastle on a windy beach.
That's a good analogy. It's incredibly difficult to keep these qubits stable and working properly.
And this is where Microsoft's Majorana 1 chip comes in, right? With a totally different approach.
You got it. They're using something called topological qubits that are supposed to be much more stable.
From what I've read, it all hinges on these mysterious particles called Majorana fermions.
That's the key. The Majorana 1 chip represents a completely new way of thinking about quantum computing.
So instead of wrestling with these super sensitive qubits, they're using these Majorana particles to create qubits that are just inherently more robust.
Exactly. They're not fighting against the instability. They're embracing a different kind of stability.
Okay, so let's dive into these Majorana particles a bit. The report mentioned that they were first theorized, like way back in 1937, but they've been incredibly elusive.
Yeah, physicists have been searching for them for decades.
So what makes them so special, so different?
Well, the thing about Majorana particles is they're their own antiparticles.
Hold on, antiparticles, isn't that like Star Trek stuff?
It sounds like science fiction, but it's a fundamental concept in particle physics. Every particle has an antiparticle. It's like its mirror image with the opposite charge.
Okay, so matter and antimatter.
Right, and when a particle meets its antiparticle, they annihilate each other in a burst of energy. Poof, gone.
So they basically cancel each other out.
Exactly. But here's the thing about Majorana particles. They're both the particle and the antiparticle at the same time.
Wait, so they would annihilate themselves. Wouldn't they just constantly be popping in and out of existence?
Well, it's not that simple. They don't exist in isolation. They only show up as quasi-particles, kind of like shadows or echoes of particles in certain materials under very specific conditions.
So they're like these ghostly particles that only appear when the conditions are just right.
You could say that. And it's this elusiveness that makes them so intriguing for quantum computing.
Okay, I'm following so far. But how do these Majorana particles actually make stable qubits?
Well, in the Majorana 1 chip, the information isn't stored in a single qubit, but rather it's encoded non-locally, kind of spread out, across a network of these Majorana particles. This approach is what we call topological quantum computing.
So instead of putting all your eggs in one basket, you're spreading them out across multiple baskets.
Exactly. And because the information is distributed, it's much harder for errors to mess things up.
Like a secret code divided among multiple spies. Even if one gets captured, the secret is safe.
That's a great analogy. Even if one part of the system is disturbed, the overall computation remains intact.
Okay, that's starting to click. We've got these Majorana particles, which are their own antiparticles, and they're forming these super stable qubits because the information is like distributed across the network. But how are these Majorana particles actually created? What's the secret ingredient in this Majorana 1 chip?
The magic ingredient is a special material called a topoconductor.
A topo what?
A topoconductor. It's a hybrid material, a combination of indium arsenide and aluminum.
Sounds exotic.
It is. It has some pretty mind-bending properties. And under the right conditions, these topoconductors can actually host Majorana particles.
So the topoconductor is like a breeding ground for Majorana particles, and then those particles are used to create these super stable topological qubits.
Exactly. The topoconductor provides the perfect environment for those elusive Majorana particles to emerge. And because they have these unique properties, we can manipulate them to form qubits that are incredibly resistant to errors.
So it's like the topoconductor is the stage, and the Majorana particles are the actors putting on this incredible quantum show.
I like that analogy. And what's even more amazing is that Microsoft has actually built a chip that takes advantage of all of this. That's the Majorana 1.
So let's talk about the chip itself. How have they managed to put all of this mind-blowing physics into a working device?
Well, at the heart of the Majorana 1 chip is what they call the topological core.
Okay, break that down for me. What's so special about this core?
This is where the magic happens. They've basically engineered a tiny wire made of that special indium arsenide and aluminum mix to create the topoconductor. And it's in this core where those Majorana particles emerge and can be manipulated to form the qubits.
So it's like a tiny controlled environment where these particles can exist and do their thing.
Exactly. But the topological core is even more impressive than that. It offers 3 key advantages. We've already talked about topological protection, but there's also scalability and speed.
Okay, those sound pretty important, but what does scalability mean in this context?
Well, one of the biggest challenges in quantum computing is building systems with enough qubits to actually tackle complex problems.
So more qubits means more power.
You got it. And the Majorana 1 chip's topological core is designed to be scalable. It has the potential to pack in over 1 million qubits onto a single chip.
1 million qubits on one chip. That's crazy. How do they manage to cram so many qubits into such a small space?
That's where the unique nature of topological qubits really shines. Traditional qubits are so sensitive that keeping them stable requires a lot of space and complex controls. It's like trying to keep 1 million butterflies from fluttering away.
Sounds like a nightmare.
It kind of is.
Yeah.
But these Majorana-based qubits are much more robust, they're less prone to errors, so they can be packed in much tighter.
So it's like the difference between storing 1 million eggs individually in fragile containers versus having them all snugly packed in a honeycomb.
That's a great analogy. The Majorana 1's approach takes advantage of that inherent stability.
Okay, so we've got stability and scalability. Now let's talk speed. How does this chip stack up in terms of processing power?
Well, the speed of a quantum computer is all about how quickly it can perform quantum operations.
So how many calculations it can do per second, basically?
Something like that. And early indications are that the Majorana 1 is incredibly fast. It can perform these operations much faster and with less interference compared to other types of qubits.
So we're talking stable qubits, massive scalability, and blazing fast speeds. It's starting to sound like the holy grail of quantum computing.
It definitely has the potential.
But there have to be some challenges, right? It all sounds a bit too good to be true.
You're right to be a little skeptical. It is still very early days for this technology.
So what are the biggest roadblocks? What's standing in the way of this quantum future everyone's talking about?
Well, one of the biggest challenges is, we need more proof.
Proof.
Yeah, experimental proof. The theory behind these Majorana zero modes, these things that make the topological qubits work, it's solid, but we need to see it in action on a larger scale.
So it's like we have the blueprint for a skyscraper, but we need to actually build it and make sure it can withstand an earthquake.
Exactly. We need to make sure these Majorana qubits can hold up their stability, their coherence, in a much bigger, more complex system.
And how confident are the researchers that they can pull this off?
Well, the report you shared does point to some very promising results. They've managed to create and manipulate these Majorana zero modes in a lab setting.
Mm-hmm.
And the initial results are really encouraging. But to scale that up to 1,000,000 qubits, that's a whole different ballgame.
It sounds like they're still laying the foundation. What are some of the engineering challenges they're facing?
Well, even just building a chip with 1,000,000 qubits, any type of qubits, is a massive feat of engineering. You're talking about manipulating matter at the atomic level with incredible precision. And then with the Majorana 1 chip, you have the added challenge of controlling these Majorana particles that are like incredibly elusive. They need very specific conditions to even exist. It's like trying to herd cats.
But invisible cats.
Exactly. Invisible cats that only appear when you do a very specific dance.
Okay, so it's not just building the chip, it's about building this whole ecosystem to control and manipulate these super delicate quantum states.
You got it. It takes a village.
A village of physicists, engineers, material scientists, the whole shebang.
And computer scientists, don't forget them. They're the ones who figure out how to actually talk to these quantum systems.
Right, of course. It sounds like there's a lot of excitement and momentum behind this technology,
Definitely.
but we can't forget about the competition.
Oh, yeah, the quantum race is on.
It's like the space race of the 21st century.
I'd say so. You've got all these big players, Google, IBM, Intel, all vying for quantum supremacy.
And they're all taking different approaches, right? Like Google's got their superconducting qubits and IBM's got their trapped ion qubits.
Right. There are multiple paths to quantum computing, and each one has its own pros and cons. Superconducting qubits are probably the most mature technology right now. Google's made some impressive strides with their Sycamore processor, but they're still very sensitive to noise. They need to be kept super cold, close to absolute zero.
So it's back to that sandcastle on a windy beach analogy.
Pretty much. Then you've got trapped ion qubits, which are much more stable, but they're harder to scale up. It's like comparing a race car to a truck.
Okay, I see the analogy. Each one has its strengths depending on what you're trying to do.
Right. So where does that leave the Majorana 1 chip?
Yeah, where does it fit in this whole quantum landscape? What makes it stand out in this race for quantum supremacy?
Well, like we've been talking about, the topological qubits in the Majorana 1 chip offer a unique combination. They're more stable than superconducting qubits and potentially easier to scale up than trapped ion qubits.
So maybe it's like a hybrid vehicle, combining the speed of a race car with the robustness of a truck.
That's a good way to think about it. And that's why there's so much buzz around this technology. It could potentially leapfrog the competition and really bring about a new era of quantum computing.
Okay, so let's say Microsoft pulls it off. They overcome all these challenges. They build this 1,000,000 qubit processor based on the Majorana technology, and it works perfectly. What does that world look like? What kind of impact could this have?
The possibilities are pretty mind-boggling, to be honest. Imagine designing new materials, atom by atom, leading to breakthroughs in everything from energy to transportation. We could simulate complex molecules to create personalized medicine tailored to your specific DNA.
That's like next level healthcare.
It is. And think about AI quantum computers could totally revolutionize machine learning.
The AI that can think and learn like us, but at warp speed, that's both exciting and kind of scary, right?
Definitely raises some big questions about the future.
Yeah.
But let's not get ahead of ourselves. We're still at the beginning of this quantum journey.
True. But it's a journey with enormous potential, and this Majorana 1 chip could be a crucial step in unlocking that potential. But, we've been talking a lot about the technical stuff. What about the practical side? How will this actually affect people's lives?
That's the million-dollar question, and we're just starting to scratch the surface. One area where I think we'll see a big impact is in personalized technology.
Yeah.
Imagine your smartphone, your car, even your house, all powered by quantum computers that can adapt to your needs and preferences.
So instead of a one-size-fits-all smartphone, I could have one that's designed just for me, based on how I use it, what I'm interested in.
Exactly. Your phone could even anticipate your needs, suggesting apps or information that's relevant to you in that moment.
That's both incredibly convenient and a little creepy, isn't it? Like, how much does my phone really need to know about me?
That's a valid concern.
Yeah.
And it highlights the importance of ethics as this technology evolves. We need to be very careful about privacy and data security and make sure this power is used responsibly.
It's like we need a whole new rule book for this quantum age.
We do. The ethical implications of quantum computing are just as important as the technical ones.
Right. It's like, how do we make sure this immense computing power is used for good? How do we prevent it from being used for bad things like increasing inequality or even oppression?
Those are the tough questions we need to answer. And as this technology becomes more powerful and more accessible, we need to have clear guidelines and regulations to make sure it's developed and used responsibly.
It's almost like we're at a fork in the road, you know? One path goes to this amazing future where quantum computing solves our biggest problems and makes life better for everyone. And the other path, well, it leads to a future where this power is in the wrong hands, used for control and maybe even harm.
It's a stark choice, and one that we need to make as a society. We can't just blindly follow the path of technology without considering the consequences.
So what can we do? How do we make sure we're steering this quantum ship in the right direction?
Well, first and foremost, we need to have open and honest conversations about the potential risks and benefits of this technology. We need everyone at the table, the public, policymakers, scientists, all working together to understand how this could impact society.
So we need like a global quantum ethics council or something.
That's actually not a bad idea. There are already some groups working on ethical frameworks for AI, and a lot of those principles could apply to quantum computing too.
So it's about learning from the past, from other technologies, and applying those lessons to this new quantum world.
Exactly. We don't have to start from scratch, but we do need to be proactive and really think ahead. We need to anticipate the challenges and put safeguards in place before they become real problems.
It's about being responsible with this incredible technology, making sure it's used to benefit humanity.
And make sure it benefits all of humanity, not just a select few. That means addressing bias in algorithms, ensuring equitable access, and protecting against misuse.
It's a big responsibility, but it's one we need to take seriously. If we can get this right, if we can use quantum computing ethically, then the future is incredibly bright.
I agree. The potential for positive change is huge. We could see breakthroughs in medicine, energy, material science, you name it. We could solve problems that have been around for centuries and create a world that's more just, more sustainable, and more prosperous for everyone.
It's a future worth fighting for, and it starts with conversations like this, with raising awareness, asking tough questions, and really challenging ourselves to think about the implications of this technology.
Well said. It's time to move past the hype and the fear and have a real conversation about what kind of future we want to create with quantum computing.
Well, this deep dive into the Majorana 1 chip and the world of quantum computing has been amazing. I feel like I've gotten a glimpse into a future that's both thrilling and a little daunting. But more than anything, I feel hopeful that we can use this technology to make a real difference.
I feel the same way. It's an exciting time to be alive, to be witnessing the birth of a new technological era. And it's up to all of us to shape this era, to guide it toward a future that benefits all of humanity.
And for those of you listening, I hope you're feeling inspired to learn more, to ask questions, and to join this important conversation. The future of quantum computing is being written right now, and your voice matters. Thanks for joining us on this incredible journey. It's amazing to think that just a few years ago, quantum computing was like this fringe science, something out of a movie.
Yeah, it seems so far off.
And now we're talking about chips with 1,000,000 qubits, the potential to like completely change entire industries. It's incredible.
It really is. The progress has been remarkable. And the Majorana 1 chip, with its unique approach, it could be a major driving force in this quantum revolution.
But it's not just about the tech itself, right? It's about how we use it.
Absolutely.
As we move into this quantum future, we need to be asking ourselves some tough questions.
For sure. The ethical implications of quantum computing are huge, maybe even more important than the technical challenges themselves.
Right, like how do we make sure this incredible power is used for good? How do we prevent it from making existing problems, like inequality, even worse?
Those are critical questions. And as this technology becomes more powerful, more widespread, we absolutely need to have ethical guidelines, regulations, to ensure it's used responsibly.
It's like we're at a crossroads, you know? One path leads to this amazing future where quantum computing helps us solve big problems, makes life better for everyone. The other path, well, It leads to a future where this power is misused, maybe even used for control and oppression.
That's a powerful image, and it's very real. This is a choice we have to make as a society. We can't just let technology run wild without thinking about the consequences.
So what can we do? How do we make sure we're on the right track, heading towards that positive future?
Well, for starters, we have to talk about it openly and honestly, about the potential risks and benefits of quantum computing. We need everyone involved, the public, policymakers, scientists working together to understand how this will affect our lives.
So like a global quantum ethics council, something like that?
I like that idea. Actually, it's not that far-fetched. There are already groups working on ethical frameworks for AI, and many of those ideas could be applied to quantum computing as well.
So we can build on what we've learned from other technologies and use those lessons to navigate this new quantum landscape.
Exactly. We don't have to start from zero, but we do need to be proactive, think ahead, anticipate the challenges, and put safeguards in place before they become real problems.
It's about being responsible stewards of this technology, making sure it benefits all of humanity.
That's the key. It has to benefit everyone, not just a few. We need to address bias in algorithms, ensure equal access, and make sure it's not used for the wrong reasons.
It's a big task, but it's essential. If we get this right, if we use quantum computing ethically, the future is incredibly bright.
It is. The potential is just enormous.
Mm.
Think about breakthroughs in medicine, energy, material science, so many areas. We could solve problems that have plagued us for centuries, create a world that's fairer, more sustainable, more prosperous.
It's a future worth striving for.
Absolutely. And it starts with conversations like this. Raising awareness, asking the tough questions, challenging ourselves to think deeply about what this technology means for us.
Well said. It's time to move past the hype and the fear and really engage in a meaningful dialogue about what kind of future we want to create with quantum computing. This deep dive into the Majorana 1 chip and the whole world of quantum computing, it's been pretty mind-blowing. It feels like a glimpse into a future that's both exciting and a little bit scary. But more than anything, I feel a sense of hope that we can use this technology to really make a difference for the better.
I agree. It's an amazing time to be alive, to witness the birth of this new technological era. And it's our responsibility, all of us, to shape this era, to make sure it leads to a future that benefits everyone.
And for those of you listening, I hope this has inspired you to learn more, to ask questions, to be a part of this important conversation. The future of quantum computing is being written right now, and your voice matters. Thanks for joining us on this incredible journey.